Okay, guys. So when we left off last week, um, we were on this slide, and you had some homework that you had to look up, and hopefully you found these answers back in your slides. Now, I may have worded them a little bit differently, but kids basically, Captain Obvious Kepler said that the planets move. He didn't know why or how, but he said that they moved. And Newton came along and said, oh, well, it's because of gravity. Okay. All right. Let's go on to this week. Now, kids, you know this. What do you think causes the Earth to have changing seasons? Now, I've heard everything from rotation to revolution to orbit. Kids, I think the best answer is the axial tilt, because that's what actually determines whether we're facing towards the sun or away from the sun. So kids, if you don't think that you'll remember that, why just add a little text box down here and put that in your notes. Now, the next slide, kids, the Earth rotates on its axis in a counterclockwise, and obviously I can't type, in a counterclockwise direction. Now, the only planet that rotates in a clockwise direction is Venus. And kids, we got that information by going back to, like, I don't know, slide 9 or 10. I don't remember. But it's in our notes. Now, kids, so the next slide, the rotation of the Earth causes all parts of the Earth to experience periods of daytime and nighttime. It's what are we getting sunlight? Are we not getting sunlight? So kids, 50% of our planet is experiencing daytime at any given moment. Now, kids, if we're in daytime halfway around the world, in Japan, it would be nighttime. So kids, you need to look at what part of the world are we in and what is on the other side of the world. All right. Oh, did I get everything on that one? Yep. Okay. Now, kids, looking at the picture, it tells us everything we need to know. Kids, it takes 24 hours for the Earth to complete one rotation on its axis, which, remember, is an imaginary line. We call this period a day, but really it includes the night as well. And I think, kids, as scientists, we talk about the day, daytime, daylight, because so much of science depends on the light or the energy from the sun. I think that's why. Okay. Looking at the picture, kids, it tells us everything that we need to know. Kids, one complete revolution around the sun takes 365.25 days, or 1 year. Kids, so a rotation takes 24 hours. Kids, the Earth is rotating the whole time that it is revolving around the sun in its orbit. Remember, kids, orbit is a pathway. Now, kids, so the way that the sunlight hits the Earth, kids, kind of is pretty important. It determines how long our days are. Kids, it determines how much energy can we expect. We just put in all of those solar panels, and kids, we're going to be putting in more of those. So it's kind of important. So kids, the number of hours of daylight and the intensity of the sunlight that a place receives, kids, they vary in predictable patterns, depending on how far north or south they are from the equator. And so we don't often think that the equator is very important, but kids, really, it is the basis of our determining weather. and temperatures. Okay. Now, maybe not, maybe. Okay. Now, kids, so this line I drew on here to kind of show you where the equator is. Kids, I think it's a little off, but not too far. Kids, this slide, I put in a line to show you where Montana is in terms of being north of the equator. Now, kids, always, 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 we're looking at the length of daylight, but kids, here on the lines of latitude, 0 is always going to be the equator. And so if you think that you'll forget that, kids, you might want to add a text box or add a little note down here in your speaker notes. So kids, we are between 45 and 49 degrees north. Kids, we are between the 45th and 49th parallel. Now, when we're talking about latitude, kids, I always remember latitude ladder. Like a ladder, you go up and so, or down, depending on where you're at. Kids, so the latitude lines are the latitude ladder of the earth. We either go up or down. Kids, this is where Montana is, right in through here. And so when I ask you, what is the difference between daylight hours of the summer solstice and the equinox, kids, you're going to take this subtracted from this, okay? You're going to take this subtracted from this. Now, obviously, kids, you're going to have to go the other way. So you're going to have 12 minus 9 hours and 8 minutes, okay? Or kids, you could possibly go this route, the 50 hours, but I think it would be better if we here in Billings, Montana, stuck to the 40th latitude, okay? All right. Now, kids, get this done. Get this orange square done for next Monday, next week sometime. All right. Now, kids, this is a great little video talking about how much daylight there is around the world. This slide, kids, we're talking about the uneven heating of the earth. Now, kids, so the sun is a lot bigger than the earth, and it directs its radiation towards the earth. Kids, depending on the tilt that the earth is having at that time, kids, it's going to determine who gets hit most directly. And so kids, they're going to have the most daylight, and they're going to have the hottest temperatures. Now, this variation in where the sun's rays hit, kids, is going to explain why temperatures change over the course of the year and at different locations. Now, kids, so the equator is probably right along here. And these words over here, kids, are going to be the answers to your other orange slide for the day. Yes, dear, what can I do for you?
Were you just recording?
I am recording. Just lay it down. Thank you, and you may go. Okay. So kids, remember these words over here will help you answer your questions later. All right. Kids, areas near the equator, kids, sun's rays spread over a narrow area. Okay, so there it's going to stay warm pretty much all year, and it's going to receive, due to receiving direct and intense light. Okay, at the North Poles, guys, it hits a bigger area, and so it kind of spreads out, and so kids, the North and South Poles stay cold all year due to receiving light that is spread out or indirect, and certainly not as intense. So those are going to stay cooler than right here at the equator. And if you look, kids, there's not that much difference between those areas, but kids, that's where we get medium temperatures, medium hot and medium cold, and not for very long. So, and that's, we're falling right about in here, right about halfway. Okay, now, kids, on this picture, I want you to fill in these little boxes, these little text boxes. Kids, notice on here, we have the northern hemisphere, and it's the exact opposite of the southern hemisphere. So when we're experiencing winter in the northern hemisphere, kids, you are right about here. Okay, in the summer, in the southern hemisphere, kids, they are experiencing summer. Now, what I want you to do is go through and look at each picture and tell me, is the northern hemisphere tilted towards the sun or away from the sun? Okay, so you need to add those into those squares. Now, kids, the next slide. The equinox, honey, come back in a little bit. Give me 5 minutes. The equinox kind of sounds like equal. Kids, it's the time when the sun is directly above the equator. The equator, kids. And the equator kind of sounds like equal. Well, kids, it divides the planet in half. We've got half of the planet to the north and half of the planet to the south. And kids, that's just a easy way of saying hemisphere. Both hemispheres receive the same amount of sun when we are in the equinox. And kids, we have an equinox in the spring and one in the fall. And it's just one day when we get 12 hours of daytime, both in the north, and 12 hours of daytime in the south, in the southern hemisphere. Okay. All right. Very good. Very good. Now, kids, this last slide for today, kids, name the lines of latitude. There are 5 lines. Kids, remember I told you that if you go back to this slide, right here are the lines of latitude. So kids, you just need to write them in or type them in to this slide. Now, if you have any questions, please feel free to Gmail me. Hopefully this will help and will do good on your quiz. The quizzes that I've seen from last week, are wonderful. Keep up the good work, guys. Bye-bye. I'm going to figure out how to work this yet.